So in this video, we're going to talk about how to solve trig equations that involve multiple angles. So in each of these cases, we've got a cosine and a tangent here, and they've each got multiple angles inside. So they've got a cosine of 2x and a tangent of 3x, each equaling a constant. So really, when we solve these, we have to account for a variation in the period. So this 2 right here and the 3 right here, they're going to change how many rotations we get in the same interval of 0 to 2 pi. So the way we're going to start these is, the first thing we're going to do is we're going to substitute here. We're going to say that we're going to let theta equal 2x. So really what we have here is that the cosine of theta is equal to 1/2. Okay, so if we look at our unit circle, or we imagine our head, the cosine of what angle equals 1/2? Well, there's two places that the cosine of theta equals 1/2, and that's going to be at pi over 3. And then, so we can say that theta is equal to pi over 3. And then again, it's going to happen when theta is equal to 2 pi over 3. So in both these cases, if we were just concerned with the value between 0 and 2 pi to start, and we had a period of 2 pi, we don't have to worry about additional rotations because we're all set. However, because we're going to change the period, we want to consider all possible values. So we're going to imagine, well, what if we rotated more than one time? It might still be within this value because we've changed the period. So if I want all possible values of theta here, it's got to be pi over 3 plus each additional rotation, which would be 2 pi radians more times n, the number of rotations. And the same thing here. We'd have theta is equal to 2 pi over 3 plus 2 pi n, where n is again the number of additional rotations. So now that I've done this, what I'm going to do is I'm going to plug this 2x back in for theta. So I'm going to get 2x is equal to pi over 3 plus 2 pi n. And in order to get x by itself on both sides, I got to divide by 2. So that's going to give us x is equal to pi over 6 plus pi n. All right, where n again is the number of additional rotations. So if I do the same thing with this one, where we're going to take that 2x, we're going to plug it back in for theta. So we're going to say that 2x is equal to 2 pi over 3 plus 2 pi n. And we have to again divide both sides by 2. And that's going to give us x is equal to pi over 3 plus pi n. Okay. So in each case, we're accounting for all the possible rotations. Now we just have to figure out, well, how many can we get to between 0 and 2 pi? So what we're going to have to do in each case, we're going to just have to test different values of n starting with 0. So if n is equal to 0, that means that the values of x we can get, if n is 0, that eliminates this part here. We end up with x is equal to pi over 6 plus 0, which is just going to be pi over 6. Over here, if we end up with n equal to 0, we're going to get pi over 3 plus pi times 0. That's just going to be pi over 3. Let's erase that straight mark there. X could equal pi over 3. Well, those are both beneath 2 pi, so we're not at 2 pi yet. So let's try again. Let's say that n is going to be equal to 1. So if we increase n, that means we've got another full rotation. So what we'll do is we'll say that, all right, we have pi over 6 plus pi times 1. In other words, pi over 6 plus pi. Well, that means that we're going to get x is equal to 7 pi over 6. Or if I do pi over 3 plus pi, that means we're going to get 4 pi over 3. So x could also equal 4 pi over 3. Well, again, both of those, oops, forgot the pi there. Both of those are going to be less than 2 pi, so we have to keep going. All right, so we'll scroll down a little bit. We'll say, well, what happens now if n is equal to 2? So if n is equal to 2, we end up with pi over 6 plus 2 pi. Well, anything plus 2 pi is going to be, anything positive plus 2 pi is going to be more than 2 pi. So pi over 6, I'm adding 2 pi to it. that's going to take me outside my desired range here. So if n is equal to 2, this one here is going to be too much. So that one there is not going to work. Same thing in this case here, where if we do pi over 3 plus 2 pi, it's going to be more than 2 pi, and we're not going to get any kind of an answer. So in this case here, we only ended up with 4 possible solutions, which would have been pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. So those would be our possible solutions here for x. Well, let's look at the tangent real quick. All right, we're going to start the same way. We're going to say that, all right, let's let theta equal whatever's inside the tangent. That's going to be 3x. So that means now that we have the tangent of theta is equal to 1. Well, the tangent of theta equals 1 at 2 places on the unit circle. It equals 1 at pi over 4, and theta equals, or the tangent of theta equals 1 when theta is 5 pi over 4. Okay, and like we did over here with the cosine, we want to make sure we're adding additional rotations just to be sure that when we adjust it, we're still going to be between 0 and 2 pi. We're going to get all the possible values. The difference is that with the tangent, the period is not 2 pi. For the tangent, the period is pi. So that means that for each of these, we're going to be adding pi radians every time that we rotate. So pi n means that we're going to add pi radians for n rotations. All right, same thing here, plus pi n. Okay, but now another interesting thing happens with the tangent here is that this value here, if I have pi over 4 and I add pi to it, I'm at 5 pi over 4. So this solution here is actually going to include all the solutions I would get here. So I don't actually need to use this one here. I can just focus on this one here because it like I said, it includes all the ones that this would otherwise give me. So now that we know this is the case, we're going to take the 3x and we're going to plug it back in. So 3x is equal to pi over 4 plus pi n, and we're going to divide both sides by 3, and that's going to give us x is equal to pi over 12 plus pi n over 3. And we want to make sure that we account for all possible values that are within 0 to 2 pi. So we're going to start plugging in values of n, and we'll work our way through. Let's start with n is equal to 0. Well, if n is equal to 0, then this here gets canceled out, and we end up with just x is equal to pi over 12. That's an easy one. Oops. Hit the wrong button here. Pi over 12. There we go. All right. Well, if we go back and we say that n is equal to 1 now. Well, if n is equal to 1, we're going to have pi over 12 plus pi over 3. And pi over 12 plus pi over 3 is going to end up equaling 5 pi over 12. So x here is going to be 5 pi over 12. All right. Still less than 2 pi. So we're going to keep going. So let's say that n is equal to 2. Well, n is equal to 2. That means that x is going to have to equal pi over 12 plus 2 pi over 3. Well, pi over 12 plus 2 pi over 3, that's going to give us 9 pi over 12. Okay, and then again, that's just pi over 12 plus 2 pi over 3. And 9 pi over 12, remember, can be reduced to 3 pi over 4. Okay. Well, again, 3 pi over 4, still less than 2 pi, so we're going to keep going. So let's say that n is equal to 3. Well, if n is equal to 3, that means that we have x is equal to pi over 12 plus 3 pi over 3. 3 pi over 3 is really the same as pi. So pi over 12 plus pi is going to be 13 pi over 12. Okay, and 13 pi over 12 is still less than 2 pi, so we keep going. Next we'll say, all right, well, what happens if n is equal to 4? Well, if n is equal to 4, we're going to have pi over 12 plus 4 pi over 3. And pi over 12 plus 4 pi over 3 is going to be 17 pi over 12. So we'll say that x is equal to 17 pi over 12. 17 pi over 12, still less than 2 pi. Keep going. Let's say n is equal to 5. Okay. Well, if n is equal to 5, that means we get pi over 12 plus 5 pi over 3, and that's going to bring us to 7 pi over 4. So I can say here that x is equal to 7 pi over 4. All right, because if n is equal to 5, that would end up equaling pi over 12 plus 5 pi over 3 would be 21 pi over 12, and that would reduce to 7 pi over 4. All right, next, if n is equal to 6, so if we said that, all right, n is going to equal 6, well, just like we ended up with over here, if I plug in a 6 for n, that means I get pi over 12 plus 6 pi over 3, and 6 pi over 3 is really 2 pi. So if n is equal to 6, this is going to be pi over 12 plus 2 pi. It's automatically going to be more than 2 pi, so this one here will not work. So my possible solutions for x, for the tangent of 3x equals 1, are going to be pi over 12, 5 pi over 12, 3 pi over 4, 13 pi over 12, 17 pi over 12, and 7 pi over 4. Okay, so I hope this video helped a little bit. I know the process, especially with the plugging in n, can get a little bit repetitive, a little bit tedious, but the more you write it out, the better off you're going to be, because you're going to make fewer mistakes that way. So like I said, I hope this helps, and I'll see you in the next video.